Good day, class. This is Sir Bren, and I am here to introduce the basic calculus lesson for quarter 4, week 1. Okay, we have finished the lessons from quarter 3. The first lesson is about illustrate an antiderivative of a function. Take note that antidifferentiation is the inverse operation of differentiation, or integration is the inverse of taking the derivative. By definition, a function f, big F, is an antiderivative of the function small f on an interval I if f, big F prime of x is equals to small f of x for every value of x in I. To give you an example of that, prove that an antiderivative of small f of x is equals to 12x squared plus 2x is big F of x is equal to 4x cubed plus x squared. That f prime, the big letter f prime of x is equals to f of x. Ibig sabihin, kung kinuha natin yung derivative nitong big f of x, ang magiging sagot niya is the small f of x. So, let's try, no? So, the big f of x is equals to 4x cubed plus x squared. So, taking its derivative, f prime of x is equals to 3 times 4, this is 12. X 3 minus 1 is 2 plus 2 x 2 minus 1 is 1. So, since parehas ito at saka yung ating f of x, therefore, the statement holds true that the antiderivative of small f of x is equals to 12x squared plus 2x is, in fact, the big f of x is equals to 4x cubed plus x squared. Furthermore, ibig sabihin nito that the integral of small f of x is equals to big f of x. So, let's try, no? Bago tayo pumunta sa theorems of antidifferentiation. So, we'll take the integral of f of x. So, we take the integral of 12x squared plus 2x dx. So, by taking the integral of each function, so taking the derivative of each function, 12, and then we have x, 2 plus 1 is 3 over 3 plus the second function, 2x, 2 x squared over 2 plus c. So this becomes 12 divided by 3 is 4. And then this cancels. So the answer is 4x cubed plus x squared plus c. So this one is correct. Okay, para maintindihan yung anti-differentiation or integration, pumunta tayo sa mga theorems of antidifferentiation. Meron tayong 4 na common. So the first theorem is the integral of dx is equals to x plus c. Magbigay tayo ng example. So let's say we want to take the integral of 5 dx. Ilalabas natin yung 5 and then we integrate 1 dx. So, meron tayong imaginary 1 dyan, pero hindi na natin isusulat. Okay, then 5. So, we get the integral of dx. So, sabi natin, ang integral of dx is x plus c. So, we write x plus c. Okay, as you notice, no, meron tayo ditong plus c. So, wag niyong kalilimutan ilalagay yung constant of integration na plus c lagi when we integrate each function. Okay? We now go on to the second theorem. The second theorem states if n is any real number and n is not equal to negative 1, then the integral of x raised to n dx is equals to x raised to n plus 1 over n plus 1 plus c. Okay, magbigay tayo ng isang example. So we integrate x to the fourth dx. So, by the formula, then we have x raised to 4 plus 1. And then, gagayahin natin yung 4 plus 1 dun sa denominator. And then, plus c, which is the constant of integration. Okay, then x, 4 plus 1 is 5. And then, over 4 plus 1 is also 5 plus c. Okay, so hindi na natin siya masisimplify. Ganito na siya. So, the answer is x raised to 5 over 5 plus c. We now go to the third theorem. It states that if a is any constant and f is a function, then the integral of a times the function dx is equals to, lalabas natin yung a, and then we get the integral of f of x dx. So, bigay tayo ng isang example. So, let's say we have the integral of 10 x to the 4th dx. So, yung una natin gagawin is we place the constant outside the integral sign, and then we integrate x to the 4th dx, di ba? So, yung x to the 4th dx, ito yung f of x, di ba? Okay, so now we integrate. So, the integral of x to the 4th, sabi nga natin doon sa theorem number 2, that we add 1 to the exponent. So, x 4 plus 1 is 5. And then, yung denominator is also 5. And then, we add plus c. And then, since na nakakancel ito, so 10 divided by 5 is 2. X to the 5th power plus c. So, the answer is 2x to the 5th plus c. We now go on to the fourth theorem. If f and g are functions defined on the same interval, the integral of f of x plus or minus g of x dx is equals to the integral of each function. Okay, so magbigay tayo ng isang example. So let's say we get the integral of x cubed plus x plus 1 dx. So kung i-rewrite natin yan, each function, x cubed dx plus integral of x dx plus 1 dx. So we get the yung integration for each function. X 3 plus 1 is 4 over 4 plus yung pangalawa, x is 1 plus 1 is x raised to 2 divided by 2. And then yung third, yung integral of 1 dx is x. And then we place plus c. So this is the final answer. Okay, to give you more examples, no? Let's say we want to integrate f of x is equals to 2. Ibig sabihin yan, we integrate or the integral of 2x dx. Okay, we place 2 outside and get the integral of x dx. 2, then x is 1 plus 1. So, meron tayong imaginary 1 yan kasi. Kaya 1 plus 1 is 2 over 2 plus c. Since makakancel ito, the final answer is x squared plus c. Okay, another example, So, this one, x to the 5th. So, we can rewrite this one when we integrate is the integral of x to the 5th dx, di ba? So, sabi natin, x, the exponent plus 1 is 6 divided by 6 plus c. So, the final answer is this one. Okay, more examples. So, let's say we get the integral, or we integrate f of x is equals to 3x cubed. So, we can write this one as integral of 3x cubed dx, di ba? So, gagawin natin, ilalabas natin yung 3, and then we integrate x cubed, di ba? So, x, 3 plus 1 is 4 divided by 4 plus c. So, we cannot further simplify this one. So, the final answer is 3x to the 4th over 4 plus c. Okay, final example. We want to integrate f of x is equals to x squared plus 3x. So, sabihin natin, integrate natin yung per function. So the integral of x squared is x 2 plus 1 is 3 over 3 plus integral of 3x, labas natin yung 3, x 1 plus 1 is 2 over 2 plus c. So hindi na siya masisimplify, kaya ito na yung ating final answer. Now, we go on to the lesson number 2. Lesson number 2 is the general antiderivative of a polynomial, exponential, and trigonometric functions. So there are 3 common theorems for the exponential and logarithmic functions. The first is the integral of e raised to x dx is equals to e raised to x plus c. So again, sabi nga natin, the antidifferentiation is the inverse of differentiation. And then napapansin natin to sa theorem number 1, the indestructible e raised to x. So ganun din, ano? So sa number 2, we have the integral of a to the x dx is equals to a raised to x over ln of a plus c. And then yung third, the integral of x raised to negative 1 dx can be rewritten as integral of 1 over x dx. So when we integrate this one, it is equal to ln of x plus c. Okay, to give examples of these 2 e raised to x dx. So this is theorem number 1, di ba? Okay, so ilabas natin yung 2 and then we integrate e raised to x dx. So 2, ito yun yung number 1. The integral of e raised to x dx is equals to also e raised to x but with plus c. So this is the final answer, no? Okay, sa number 2 example is the integral of 5 raised to x dx. Okay, so where a is a constant. Sabi niya, yung integral niya is a raised to x over ln of a plus c. So a raised to x, we just copy 5 raised to x over ln of a, which is 5 plus c. So this is the final answer. For theorem number 3, let's say we have integral of 3x raised to negative 1 dx. So sabi natin, ilalabas yung 3. And then yung x raised to negative 1 can be written as 1 over x, di ba? Dx. So now we integrate 3. Yung integral of 1 over x dx is just ln of x plus c. Okay, more examples for this theorem. Let's say integral of 3 minus 3 e raised to the x dx. So sabi nga natin, we integrate per function, diba? Integral of 3 dx minus integral of 3 e raised to x dx. So integral of 3, labas natin yung 3. And then integral of dx is just x minus, labas natin yung 3. And then the integral of e raised to x dx is just e raised to x. And then we add always plus c. So the answer is this one. So another one, let's say we have integral of e raised to 3x plus dx. Okay, so unique tong example na to kasi meron tayong nested function, no? Kung e raised to x lang yan, ang answer lang natin is the integral of e raised to x is equals to e raised to x plus c, di ba? Since meron tayong nested function, parang sa chain rule, di ba? So gagamit tayo dito ng u substitution. So yung u substitution will be another lesson after this one. Okay, that is for week number 2. Pero dahil sa example na ganito, gagamitin muna natin yung u substitution for the moment. Okay? So let yung 3x dito yung u, no? Let u be the 3x. So therefore, when we get the derivative of u, which is sinusulat siya as du, so the derivative of 3x is 3, di ba? And then we place dx. So we get dx as du over 3. So if we divide both sides by 3, so magiging denominator siya dito. So the problem here is this one, di ba? Sabi natin, this is e raised to u, and then yung dx natin, sabi natin ito, no? We have du over 3. So, ang ginawa natin u yung mga x. And then, yung dx na nakuha natin, ilagay natin dito. Okay? And then, meron tayo ditong 1/3. Diba? Du over 3 is just du times 1/3. Diba? Parang ganyan yan, no? 1/3 eu du. So, nilabas natin yung 1/3. Sabi nga natin, kung integrate natin yan, ilalabas natin yung 1/3, di ba? And then we integrate eu du. Okay? So 1/3, then the integral of eu du is just eu plus c, di ba? Okay. So after we integrate, we then now substitute the value of u to this. So therefore, the answer is 1/3 e raised to, yung u natin is 3x. So 3x plus c. Or, can be simplified as e raised to 3x over 3 plus c. Okay? So, let's move on to the theorems of antidifferentiation of trigonometric functions. We have 6 common formulas. I will now give examples for each para mas maintindihan. Okay? So, again, yung antidifferentiation is the inverse of differentiation. So, kabaliktaran siya. Okay, for number 1, example, for this one, let's say we have integral of 4 sin x dx. So, sabi nga natin, ilabas natin yung 4. And the integral of sin x dx is negative cosine x plus c. So, ilagay natin dito yung negative. Negative 4 cosine x plus c. So, this is the final answer. Okay, another example. So, let's say we have the integral of cotangent squared x dx. Okay? So, kung mapapansin nyo, class, walang cotangent squared x na formula dito. So, what are we going to do? No? Sabi nga natin, one of the Pythagorean identities is that the cotangent squared x is equals to cosecant squared x minus 1. Okay, so napag-aralan natin to sa pre-calculus, one of the Pythagorean identities. So ngayon, pwede natin ma-rewrite ngayon yan. So yung cotangent squared x dx is also the integral of cosecant squared x minus 1. Okay, so makikita natin kasi yung cosecant squared dito no, sa number 4. Now, ang gagawin natin, we integrate each function kasi ganito siya, no? Integral of cosecant squared x dx at saka integral ng minus integral of 1 dx. Okay, so now we integrate. The integral of cosecant squared x dx is ito, no? Negative cotangent x. And then minus the integral of 1 dx or integral of dx is just x. And then we have plus c. So this is the final answer. Okay, third example. So let's say we have the integral of cosine x minus sin x dx. Okay, so dalawang function yan. Mahati siya sa cosine x dx saka minus sin x dx. The integral of cosine x is ito, no? Sin x minus the integral of sin x is negative cosine x. So, ilagay natin yung negative cosine x. And then, plus c lagi, no? So, we have, therefore, sin x. Then, negative times negative is positive. Cosine x. And then, plus c. So, this is the final answer. Okay, I will give you more examples. So, let's say we have integral of 4 cosine x dx. Okay, so we place 4 outside and we integrate cosine x dx. So, sabi natin yung cosine x, the integral of cosine x is sine x plus c. So therefore, we have 4 sine x plus c. So this is the final answer. Okay, another example is the integral of sine x minus cosine x dx. So dalawa siyang function, no? So compute na natin siya agad. The integral of sine x, the integral of sine x is negative cosine x plus c. So lagay na natin siya. Negative cosine x minus the integral of cosine x is sine x. Okay? So minus sine x plus c. So this is the final answer. Okay, last example. Let's say we have the integral of tangent squared x dx. Okay, so this is also a unique problem kasi bakit wala siyang tangent x na formula dito, no? So, like we did in the previous example, we get the Pythagorean identity of tangent squared x. So, the tangent squared x equivalent is equals to secant squared x minus 1. Okay? So, ngayon, pwede pala siyang marirewrite na ganito. So, therefore, yung ito can be rewritten as secant squared x minus 1. Kasi yung secant squared, meron siyang formula dito, which is this one, no? Itong number 3. Okay? So, dalawang function siya. I-integrate natin yung secant squared x at saka yung 1. No? Okay. So, integral of secant squared x is tangent x. No? Nandito sa formula natin. Secant squared x is tangent x. And then minus integral of dx is just x. And then we place plus c lagi sa dulo. So the final answer is this one. Okay? Thank you for listening to me. And don't forget to subscribe to my channel and like this video. I will see you on the next lesson. Take care and God bless you all.